Welcome to Science Access. In today's class, I'll be continuing my naming of organic chemistry part 3. In today's class, I'll actually be telling you how to name the haloalkane, tell you how to name the alkanoic acid, the esters, the ether. We'll be talking about a lot of functional groups, how to name them. Please, for better understanding, watch my part 1 and the part 2 of this video to give you a better understanding. If you know you have not subscribed, please subscribe to support this channel. Thank you. So let's go straight to the naming of organic chemistry. Let's take a look at this. This is a very simple one. We have a very simple structure. You have an halogen group attached to this place and to this place. So it's quite easy. I can decide to name, but I will just, since in the reactivity series chlorine is higher in terms of reactivity, I will start naming from here. So let's name the longest chain as usual is 1, 2, 3, 4. So 1, 2, 3, 4. Now, the next thing that I will do is this. I know that chlorine is attached to carbon 1 and bromine is attached to carbon 2, but I will put 4 bromo. Why am I putting bromine first? It's simple. Alphabetical order. Bromine comes before what? Chlorine. B comes before what? C. 4 bromo, 1 chloro. So what is this compound? 1, 2, 3, 4, which is what? Butane. Butane. It's a very simple compound. The next one we have is this. Let's take a look at the one let's take a look at the parent chain first, as usual. So 1, 2, 3, 4. That's the longest chain. Now realize that fluorine is attached to this place and iodine is attached to this place. So I'll count from the side. I will give the functional group the lowest possible number. So even if I start counting from here, you have 2, 4. If I start counting from here, we also have 2, 4. But since chlorine is more reactive, let's start counting from here. 1, 2, 3, 4. So in this case, how will I name this compound? It's simple. 2 fluoro 3 iodobutane. And it's quite easy. I'm just doing it casually because the process is quite easy. Number 1, as usual, take the longest chain as the parent chain. Count from the side. I will give the functional group the lowest possible number. If there is branch, count from the side. I will give the branch also the lowest possible number. So these are very simple concepts. Now this one again, 1, 2, 3, 4. 1, 2, 3, 4. So the longest chain is also 4. Now we'll count from the side. I will give this branch the lowest possible number. So we have to count from this side. 1, 2, 3, 4. Now, once we've done that, bromine, B comes before what? C. So I'll have to put 2 bromo, 2 chloro, 2 butane. All right. We have showing us that we have 2 bromine in carbon 2, chlorine in carbon 2. The longest chain 1, 2, 3, 4 is actually what? Butane. Right? Let's take a look at this. This we are talking about the alkanoic acid group family. All right? This one, the first member is metanoic acid, which does not exist, but this one which does not actually exist naturally. All right, why this one have 2 carbon? 2 carbon is what? Ethane usually, but 2 carbon is actually ethane usually, but because of this functional group, we are going to name it ethanoic acid. Ethanoic acid. Right? Look at this one, the next one here. You have, what is the longest chain? The longest chain, remember here, the longest chain is 1, 2, 2. Longest chain here is 1, 2, 3. Always remember to add this carbon that carries this COH. So always remember to add it, right? 1, 2, 3. So you must start counting from that side that has this functional group. Very important. All right, 1, 2, 3. We have a methyl group at the carbon 2. So in this case, we now have 2 methyl. 1, 2, 3. The longest chain is what? 3. So propanoic acid. In some cases, some will say propa-1-oic acid, but it's not really necessary. All right. So this one we have 1, 2, 3. The longest chain is 3. Now remember, we have OH group, which is the Alkanol at carbon 2. 1, 2, 3, as I said earlier. So we have the OH group at carbon 2. Now take note, the OH group is not the functional group in this case because this one is higher in terms of hierarchy. So if this OH group is not a functional group and is going to be present as the prefix at the beginning, there's a kind of name we attach to it. It's called the hydroxy group. So we'll now put it like 2-hydroxyl. Now please take note. Is this OH that is the hydroxyl group? Now 2-hydroxyl, 1, 2, 3, propanoic acid. So these are very simple concepts. Assuming there is a branch chain here, a methyl here, you can now put 2-methyl propanoic acid. If it's a longer one, you can put 3-methyl or 2,2-dimethyl hexanoic acid. It's a very simple process. Naming of organic chemistry is a very simple process. Let's go to the next one, the esters. Now, please take note. The esters is very easy to name, but usually confuse students. Now, I'm going to give you a very simple way to name them. Just pick this first. Name this one. What is this? This is a methyl. This is methyl metanoate. Now, this one is, if you want to arrange this thing properly, it's like CHOO, C here. All right, this is like the structure. So this here, pick this last one, which is a methyl group, then name this side. So this is methyl metanoate. So we now have methyl metanoate. Now, just the way we name this one. Here, the second one, pick this side again. This and this is ethyl. All right, so this is ethyl ethanoate. You are picking this first and naming this. So this is ethyl. Remember, the reason why this is ethanoate is this side is two carbon, right? Ethyl. Then this side is also 2 carbon, ethanoate. Now, this third one, look at this. This is also 2 carbon, right? Ethyl. But how many carbon do we have here? 1, 2, 3. So this is not ethanoate. This is propanoate. So this is ethyl propanoate. Ethyl propanoate. All right. So look at the next one here. This next one is a different functional group or a different group, the ether. All right. Now, there are old ways. All these compounds that I've been naming, there are old ways to name them and there are new ways to name them. So in this case, we can decide to name this one the old way. How do we name it the old way? I can decide to say this is a methyl group, this is a methyl group. I'll now say dimethyl ether. Now, please take note. Dimethyl means there's a methyl group here, there's a methyl group here. So it's dimethyl. Then this is the functional group of ether. Now, but this is not the IUPAC way of naming it. The IUPAC name of naming is this is what? A methyl group. All right? So a methyl group, sorry. So this attached to what? This 1 here. So the iPad name of way of naming it is simple. Right? This marker is me Ozzy maintain. Now please take note. This is the methyl group met Ozzy maintain. Alright? Here now, remember this is 2 carbon ether. And here now this is methyl. So here, if you want to name it the old system, what would you do? You say ether, methyl, ester. So we can decide the old system. We can now say ethyl, methyl, ether. Ether. All right. Now this is a very old system of naming it. All right. So now let's use the IUPAC nomenclature for this. IUPAC nomenclature, we can now say this is a methyl group, right? We can now say tozi. This is maintain. So the IUPAC way of naming this is what? Tozi maintain. Ethane, ethyl, and methyl. So ethoxy methane. Remember, when we are talking about the esters, I always pick this first. Methyl methanoid, ethyl ethanoid, ethyl propanoid. Now, come to this place. I'm picking the old system. We'll just choose the 2. Dimethyl, which shows that you have 2 methyl group. Dimethyl ether. This is the ether functional group. All right. But the IUPAC nomenclature, as I mentioned earlier, you pick this first, the one at the front again, methoxy maintain. Now look at this one now. We have the old system. We have what? Ethyl, methyl, ether. Ethyl, methyl, ether. All right. But the new or the IUPAC nomenclature again is actually ethoxy maintain. Now, why the last one is now what? Ethoxy propane. But the old system will now say ethyl propyl ether. So let's write the old system first. Old system, we can do it this way. Ethyl propyl ether. Remember, ether is actually the functional or is the family that we are naming here. Why the IUPAC nomenclature for this is actually what? Ethoxy propane. Now, where does the ethane or the ethoxy come from? This 2 here is what? 2. We know that it's ethane. If you move H, it's ethyl. So ethoxy, then 1, 2, 3, propane. So you pick this first and you follow by what? This. It's a very simple system of naming. We'll be continuing our naming with other functional groups. Let's take a look at the aldehyde, how to name aldehyde. Another name for the aldehyde is actually what? The Alkanal. Alkanal is the modern name. This is actually the former name for the group. All right, so let's take a look at this compound. Let's name this compound. Now, if you take a look at this compound, we have this functional group. We have this functional group here. This is the same thing as CHO. In some ways, you just see this as CHO. All right, this we have as the hydroxy group, but this is higher than this. So we'll take this as our functional group. Then we'll now name this one as the prefix at the beginning. All right. So let's name from this side. 1, 2, 3, 4, 5. Remember, this is the longest chain regarded as the parent what? Chain. All right. Hydroxy group is present at carbon 3. Methyl group is present at carbon what? 4. So we'll start from this. 3 hydroxy 4 methyl is 5 pentanal. Remember, this Al is indicating that this functional group is in charge of this compound. All right, so this is simple name. There's no need to start putting penta-1 now. No. It's still okay. It's in the number 1 position. All right, this next compound is simply direct. This is the functional group. How many carbon do we have? 1, 2, 3. There's no branching in this. So 3 is actually propane, right? So it's simply propanal. Propanal. All right. The next one that we have here is the what? This is called the ketone group. All right. Ketone group. All right. Now, let's name this compound. Formally, the way they name it, we can name it just the way you named your esters or your ether. You pick this. This is actually what? Ethyl. This is methyl. This is ketone. So the old way of naming it, you just pick this. Ethyl. This. Methyl. Then this. Ketone. Now, indicating that we have a ethyl group, and what? The ketone. But the IUPAC way of naming it, let's name this compound. We'll start counting from the side that will give the what? The lowest possible number, which is 1, 2, 3, 4. 1, 2, 3, 4. Now, the functional group of the ketone is present at carbon what? 2. So we have 2 butanone. 2 butanone. This 2 is indicating that this functional group is present at what? Carbon what? 2. Previously we start to put the 2 in this place attached to this, but this is okay. Think for this, or you can still put it. A lot of scientists have their way, but it's basically the same. All right. Now, the next one that we have here, we have 2 functional groups. We have the ketone functional group. We have the aldehyde or the alkanal functional group. Well, please take note, this alkanal functional group take priority. All right. So in this case, we can now name this one as the prefix. Remember when we name alcohol as hydroxy as the prefix. So to name this as the prefix is ozo. Call it ozo. All right. So we'll count from the functional group side. 1, 2, 3, 4. So since this one is present, is 3 ozo. 1, 2, 3, 4. Butanal. Now this is a butanal. If you remove this functional group, this is a butanal. Now this functional group is present at carbon 3, so we put it as 3 ozo butanal. Remember, this CO is the ketone functional group. It's only because of this aldehyde that is present here that we decide to what? Change it, because it's higher in hierarchy, is changing to what? Butanal. Now, if I remove this, automatically we now have 2 butanone. If I remove this, assuming I change this to CH3, automatically the compound will change. We now have what? We can't start counting from this side so that it will give this. And automatically it's almost the same as this anyway. So we don't need to do that. All right. So please take note of that. Let's go to the amine. All right. Now we have the primary amine, secondary, the tertiary, depending on this. So this one is so easy. This one is primary amine. All right. So now this is a methyl group, methyl amine. All right. Assuming we have another methyl group for here now, it's now dimethyl amine. All right. Here now we have how many methyl group? 1, 2, 3. This is what? Trimethyl. 1, 2, 3. Trimethyl what? Amine. This is a tertiary amine. Remember, if one methyl group is attached to it, it's primary amine. If 2 methyl group is attached to the nitrogen atom, is secondary amine. And if 3 is attached to it, is what? Tertiary what? Amine. So this one, we can also have the ethyl propylamine, depending on the length of the carbon atom that is present there. So this one, we can just put this one as methylamine. This one as trimethylamine. Please take note. Why the last one that we have here is the amide what? Functional group. AMIDES. Alright? Functional group. So in this case, it's quite easy. You also name it just the way we did before. But we always take note of, always, remember to always pick the parent chain, the longest chain first. So let's count 1, 2, 3, 4, 5. Alright, so 5 is definitely pent. Alright, so we have one methyl here. We have another methyl here. So let's count 1, 2, 3, 4, 5. So we have one methyl group at carbon 2, one methyl group at carbon 3. So we have 2, 3 dimethyl. Now it's pentamide. All right. So here, take note. We have amide or amide is the the functional group. So we count from there. We have a methyl group at carbon 2. We have a methyl group at carbon 3. So we have 2, 3 dimethyl. The whole length, the parent chain is 5, which is pentane, pentamide. All right. So please just take note of that. All right. Why the last structure is we also count from the functional group. What's the longest chain? 1, 2, 3, 4. All right, 1, 2, 3, 4. So we have a methyl group present at carbon 3, 2 methyl group present at carbon 3. So we have 3 dimethyl. How many carbon? We have butane. So butamide. All right. So this is the answer to this. I'll give you a little assignment on the board for you to name. Take a look at this assignment and name this compound. You can drop your answer at the comment section. We'll definitely reply you if it's correct or not. Thank you. Please subscribe to support this channel. This is the end of naming of organic chemistry. Thank you.